So welcome back. This is the second half of the Target 21 video on I can solve radical equations. We're finishing up Unit 3 on radical functions. In this video, we will be focusing on equations that have two radicals in them. And while that might sound like it might be harder, it actually really isn't any more difficult than what we saw in the first part of Target 21. So the steps for solving are still the same. Okay, we want to isolate the radical on one side of the equation. Now, since we have two radicals, we want one radical on each side. And that's the only thing that's different about solving an equation that has two radicals versus one radical. Okay, we want to just get one radical on each side so that when we raise each side of the equation to the same power, it should eliminate both radicals at the same time. So let's take a look at a few examples. Okay, the first, we've got the square root of 2x plus 5 equals the square root of x plus 7. So notice that I already have just one radical on each side. So I'm going to go ahead and square both sides in order to get rid of those radicals. And when I do that, I end up with 2x plus 5 equals x plus 7. And that's now just a linear equation that I can solve by undoing. So I'm going to subtract x on both sides. Okay, that gives me x plus 5 equals 7. And then subtract 5 on both sides to get x equals 2. All right, so now going back and checking to see if that answer actually works. Because remember, by doing this squaring on both sides, we can potentially introduce extraneous solutions that don't actually exist. So go back to your original equation and put 2 in there. Okay, we get the square root of 4 plus 5 equals the square root of 2 plus 7. So that's the square root of 9 equals the square root of 9. Okay, that checks out. Okay, those are actually equal. So x equals 2 is a legitimate solution. Okay, moving on to the second example. Same setup here. We've got one square root equal to another square root. So we can go right ahead and square both sides, leaving us with 4x plus 1 equal to x plus 10. And again, we can solve that linear equation by undoing the operations. Getting 3x plus 1 equal to 10, and then subtract 1 to get 3x equals 9, and then finally dividing by 3 to get x equals 3. Then going back to check it, in the original equation, putting 3 in for x, we have the square root of 12 plus 1 equal to the square root of 3 plus 10. So that's the square root of 13 equal to the square root of 13, and that checks out. Which means that x equals 3 is in fact a solution. All right, moving into our final example. This time we have two radicals on the same side, which we don't want. So the first step is going to be to get one of those radicals to the other side. So what I'm going to go ahead and do is I'm going to add the cubed root of 8x plus 5, or I'm sorry, 8x plus 15, to both sides of my equation. All right, in doing that, okay, I get rid of it from this side, so now I just have the one radical on the left side, the cubed root of 12x minus 5, okay, equal to, and the right side now just has one radical, the cubed root of 8x plus 15. And now I've accomplished getting just a single radical on each side. So the next step then is to get rid of the radicals by raising both sides to the same power, okay, which in this case would be 3, since I'm getting rid of cubed roots instead of square roots. Doing that leaves me with 12x. 12x minus 5 equal to 8x plus 15, which again is just a linear equation. So we solve it by getting rid of the x from one side, leaving me with 4x minus 5 equal to 15, and then undoing the operations. So add 5, get 4x equals 20, and then divide by 4 to get x equals 5. All right, and then the final step, go back, substitute it into that original equation to see if it actually is correct. So when I check, we have the cubed root of 12 times 5 is 60 minus 5, minus the cubed root of 8 times 5 is 40 plus 15, okay, equal to 0. So this is the cubed root of 55 minus the cubed root of 55 equal to 0. So that does in fact work, which means that x equals 5 is in fact a solution. So as you can see, solving equations that have multiple radicals, and again we're only going to look at ones that have 2, are not any more difficult than when we had 1. All right, that concludes Target 21, and it also concludes Unit 3, so be preparing for your test, which is coming up shortly.